Hey everyone, here's another super quick video on a radio that I've been working on. I've done a few since my last video, but I just haven't documented them, so I thought I'd document this one. I really liked this one. This is a Uniden Pro 810 base. It came out really well. I like working on the old base stations. There's plenty of room to work on them inside, and they usually come up pretty nicely, so this one came up fairly well. First thing I do on these base stations is I put a new mains cable on them, and for this, and I try and make them a little bit safer inside. So normally the mains would come in through this block here and then come back out from this block to here. But the disadvantage of this radio is it doesn't run off 12 volts. So when a tech's working on it, they're most likely going to run off 240, or they're going to run off mains, wherever you happen to be. And there's a fairly high chance that if you're not used to working on mains electricity, you're going to electrocute yourself. So just disconnecting this all together and taking the mains straight into here, clamping those wires together, which is good practice. And then what I've done is I've siliconed up the live connections on the back of the PCB here as well. That was already broken. Not sure what happened there, but just sealing it all up like that. Now, if you're working on this radio, you're going to be pretty hard pressed to electrocute yourself. You're going to have to try pretty hard. So now it's a lot safer to work on it. The next poor bastard that decides to open it up and not going to get electrocuted. The next thing I did was I replaced the main power line, which comes out of the power supply here. Main power line for these, when it comes out of the factory, is something like this. It's just this pissy little wire. It comes from here and it goes across to this plug here. So I've put some nice heavy DC cable on here, and it just solders onto the back of the board right under here. From here, it's like super heavy, like way heavier than what I needed, but that's all I had at the time. So nice heavy cable here coming from the power supply, so I won't have any problems with voltage drop there. The other thing I didn't like about the design on this radio was, unlike the older version, the Uniden Washingtons, the microphone lead comes from the back of the mic on the older units through a shielded mic cable to the PCB, but this one actually runs a PCB track right across the front of the board here, and then back into the radio. And yeah, it has got a bit of shielding because there's a steel panel at the front, but I just really thought that was, they're obviously saving a little bit on design by just running a PCB track instead of a shielded mic cable, but I think it's pretty bad practice. So I disconnected that track and I ran a PCB, a micro, instead of that PCB track, I run a shielded mic cable from the microphone across to the PCB. I don't know if these radios had trouble with noise being picked up, but anyway, that would be the cause of it, if that's just not a great design there. So yeah, I changed that. Changed the backlighting on the LED. This phone is sort of blowing out that display, making it look pretty bad, but actually it's really quite a nice even display, and that's because I use these little LED matrix things in there. These are meant for interior car lights, run on 12 volts, but it sticks in behind the LED, behind the meter really well, and when you run on 8 volts, the output is perfect. It's really nice even light. I've got a video on doing this on another base station. Yeah, and then that just tacks in onto the back of the PCB. The front panel's got 8 volts on it, so that was a really easy mod to do. Next mod I put a serially addressed, because I'm running a micro on this, I run a serial addressed LED block, which is one of these things. These are just a couple of dollars. You can get, I think, about $2 or $3 or something like that. It runs on a 3-wire bus, and they're really easy to interface to. That just runs 3 wires back onto here. And they come in red. I didn't have green, but I thought the red probably looked okay, so I just left it as red. The other mod I did was I changed the channel 9 to be a 0. So when you press channel 9 in, it just says 0, which means now we're on the zeros. So that's 27350. And then when you bring it out, it's 5. That's 27355. So it just gives you your zeros. The next thing I did, what else did I do? This is a rotary encoder. I often try and keep the channel dial, the original channel dials in, but it was difficult with this one. It just wasn't working very well. So I've put a rotary encoder in there for channel change. Then what else? I've got echo board in here. This echo board is like, these work really well. Super cheap little echo board. They're about $5 each. It uses the same IC and the same circuit as the Anytone Quad 6 and all the rest of it. They all use this. This is sort of, it's an overkill for these things. You might think, oh, $5 is not going to be a very good echo board. They're used for surround sound systems and that kind of thing. They're good for 20 kilohertz stereo systems. Though I think they've got a sampling rate of 44 kilohertz, way beyond what the radio would need. So they actually work really well. You do have to change a few components on there. I should probably do a video just on putting these echo boards into radios, because you've got to change a few components. You've actually got to put it into the right part of the circuit. You can't hook it up to the microphone. So I might do a special video just on doing those echo boards, because as I said, for $5 you can put echo into a radio super cheap, and they sound really, really good. So so what else did I do? So I pulled the PLL chip out of here, and I've replaced all the circuitry and put like a nano in here. There's the Arduino Nano, which I use, something like that, with an edge connector on one side, and I put those plugs on the top here, just because it makes it easier to run connections into it. So yeah, and it's super strong too. And then the other board, the other side of the PLL chip, I put these 5351, put an edge connector on that, solder that straight into the board there, and that's super strong as well. The 5351's got these leads that come off it. The two oscillators that I'm using here, I run this coax cable, which is like this really fine 50 ohm RF cable, and that keeps interference of the board down a lot, because these things throw out a bit of rubbish because they're square wave basically output. So putting that output through 50 ohm coax and then terminating on the other end, I think on the back of the board I've got 50 ohms, or somewhere between 100 maybe and 50 ohms, terminating it as well. It cuts out a lot of the harmonics. I think it's the second order harmonics or something like that. I'm not really good with RF, so I think anyway it drops down the harmonics, and then the rest of the circuit kind of filters that out as well. So that's really good. Also on these boards here, I put especially on sideband units, you want to change the little this crystal here. You want to change that resonator with TCXO, which is one of these. These are 25 megahertz TCXOs. They're super accurate. They don't drift, and they're really, really accurate. So if you're doing sideband, I really suggest, like, whenever you're running one of these boards in a sideband radio, replace this, put one of these on here. There's a little bit of mucking around to do it. I've got another video which shows you how to do that. But these boards are about $3 or $4. These things are about $2 or $3. So if the extra $2 or $3 and 10 minutes work, it's well worth putting one of these on here, because then you've got this like head-on accurate, no drift reference for your radio to run on. And I'll show you how well that works in a minute. So what else? I recapped the whole thing as well, which I normally do. I get one of these old radios in, and you notice too, I've leaned all the caps away from the heat source here, so it looks a bit ugly, but the heat from this will damage these caps. Normally they're right up against it, so that's why the recap job doesn't look great, but it's going to work a lot better because those caps are away from the heat. So but I'll show you just quickly how accurate this TCXO is, because I really love these TCXOs. So I put on channel 4 and then to 0, so that'll give us 27 megahertz. 27, it should be 27 exactly. And then if I, so this, blown out, hang on. There we go. So you can see it's 27.0000013, so 1.3 hertz out at 27 megahertz. So, but it doesn't really get much more accurate than that, and that's GPS locked as well. So this thing is, like, the technical term is a dead on balls accurate. That's the official engineering term. So once you put one of these things in, your radio is going to be dead on accurate. And of course, another thing, when you've got that sort of accuracy, it's a real shame to then just go and put a clarifier in there, which is unlocked, because what's the point of being dead on accurate? And then, you've got to clarify here, which you don't know really where you are, not with that sort of precision. So what I do is I've got this little decimal point here, and then the clarifier, when the clarifier is on the 0 position, this little dot comes on. And then and it's got a little bit of a flat spot there. So you can see as I turn it each way, the little dot comes on and it tells you that it's on frequency. And like I said, there's a little bit of a flat spot there, but once you adjust that and this dot comes on and you transmit, no, you're spot on frequency. Yeah. So yeah, whenever look, if you're doing that sort of modification where you're putting a TCXO on there, and you've got an unlocked clarifier, yeah, just you got to do something like that. Like how does the person know that it's spot on accurate? So now that that's got the dot on, I know that's going to be bang on, no matter where you go. And then you can adjust it to drift off frequency if you want, but that dot's always going to show that you're spot on accurate. So yeah, all right, that's about it. Till next time. See you later.